Okay, what we're going to do is do some pre-work before we start Chapter 4. So I'm going to be calling these two sections. You're going to be dealing with one now, 4.0.1 and 4.0.2. These are concepts that are actually covered within the sections, but really doesn't have a separate lesson, and we decided that we're going to do a separate lesson for this. First part is common factoring. What's important here is we want students to be able to understand how to find a common factor. You may have learned in previous years that something called the lowest common multiple, LCM. Here, or greatest common factor, GCF. Here we're going to apply those ideas of lowest common multiple and GCF to be able to answer questions like common factoring. You're asked to basically factor each of the set of monomials. So I'm going to give you a group of monomials, such as these. And these monomials, what we have to do is find the factors. Okay, what will be the biggest number that I can take out of all of these? And then factor each binomial. We're going to look at binomials and be able to factor those as well. Okay, so here we go. In the first example, 4x, x squared, and 2x cubed, what we need to do is look at the numbers, just the numbers in the front, the coefficients. What number can I take out of all of these? Well, folks, it looks like we can only take out the number 1 because 1 is the only number that can be divided by all of these. So 1 is our number. Then we look at the variables. What letter can I take out of these? And hopefully you see that each of these contains an x, and the greatest common factor that I can take out here is an x, because I can take out an x from here and an x from here. So the idea is that I can take one x out of all of these, and that will be the greatest common factor. Okay, moving on. The next one. 7xy squared, 14x squared y cubed, 28x cubed y cubed. What can I take out of all of these? Let's look at the number first. What can I divide out of all of these? And hopefully you see, oh, I can take out a 7. So I can take out a 7 out of all of these. What else can I take out? I can take out one x out of all of these, and I can take a y squared out of all of these. So I can take out a 7x, and I can take out a y. How many y's? That's 2 y's, y squared out of all of these. So it's like dividing out, what can I divide out of all of these and still end up with a nice number. So the biggest thing I can take out is a 7xy squared. 7xy squared can be divided by all of these. Let's look at the next example. Negative 12 x cubed y squared, negative 18 x to 4 y cubed, 36 x squared y cubed. What can I take out of all of these? Some of you might be thinking, well, we can take out a 2 out of all of these. And you'd be right, but I could think of a bigger number. Some of you might be saying 3. I can take out 3 out of all of these. And yeah, you'd be right, but it's still not big enough. Some of you might be thinking 4, and you'd be wrong because 4 can't be divided here. Some of you might be thinking, let's say 9. Well, 9 can't be divided out of here, folks. What number can be taken out of all of these? Hopefully you're thinking, that's right, a 6. From negative 12, I can look at another way to look at this, you might be thinking, well, how come it wasn't 2? How come it wasn't 3? How come it wasn't, well, we know why it couldn't be 4, but how come it was 6? How come it wasn't 2 or 3? Well, here we go, folks. Let's try this. Take the smallest number and think of all the numbers that make up 12. That's one time, oops, that's too much, folks. Let's go backwards a little bit. Sorry, let's try that again. 1, 2, so out of negative 12, I can take out a 1. I can take out a 2. I can take out a 3. I can take out a 4. I can take out a 6. And I can take out 12. So look at the factors of the smallest number and see which of these will go into all of these. Now, I know 1 will go into all of these, so we can cross the 1 out. Or we can start with the biggest number. Let's try with the biggest one. Let's see 12. Can 12 be divided by all of these? We know it can be divided out of here. We know it can be divided out of here. but it can't be divided out of here. So 12 is out. Let's go down to 6. 6. Can 6 go into all of these? Well, let's see. 6 can go into here, 6 can go into here, and 6 can go into here. So folks, what we can say right now is since 6 can go into all of these, 6 is the number we want. We know 6 is the largest possible number that can be divided by all of these. So recap again, we're just going to go backwards for a second, just for a sec, so that we can see this again. So, when you have fairly large numbers like this, what you want to do is find the smallest number and find all the factors of that number. That is, for negative 12, we're going to look at 1, 2, 3, 4, 6, and 12. And starting with the largest number, we look to see if that largest number of the factors of the smallest number, the largest factor of the smallest number, can be divided by all of these. And we know that 12 can't be, but 6 could be. So our final answer is going to be 6. Now, let's look at the x's. X's, we can take out an x squared. And the y's, we can take out a y squared. So our common factor is going to be 6x squared y squared. Let's try example number 2. And it'll make more sense once we apply this knowledge into practical questions. So for example, 3x minus 9. What I want to do here is take out 3 from here, because both 3 and 9 I can divide out a 3, and I can't divide out an x because the 9 does not have an x. So what I'm going to take out is a 3, so divide out by 3 both terms, 3x and 9, and I get x minus 3 is my leftover. Again, what we do is we divide by 3 because we pulled 3 out of both of those, and we're left with, what is left? Well, 3 divided by 3 is just 1x, minus 9 divided by 3, which is 3. We do not put a 1 in front of the x, folks. That's redundant, and you'll be nailed for communication. Because it's important, mathematical communication is important for you to understand that when you see an x, there should be just x, not 1x. The next numbers, what can I divide out of these? Give yourself a moment to think. Some of you might be thinking 2. 2 is not big enough, folks. We need to find the biggest number that can divide out of all of these. Well, that'll be 4. So we divide each piece by 4, and we're left with x minus 2. If you had divided out a 2, folks, you'd have to divide out 2 again. So you don't want to do that more than you have to. Next one, what can I take out of here? Well, all this I can take out a 5 for sure. And what else? Well, I can take out 1x. So what do I have here? 5x squared over 5x means that I will be left with 5x on the outside. And on the inside, I'm going to be left with x minus 8. And that'll be the inside. All right, let's try the next one. 9x squared y squared minus 3x squared y. What are we looking at here? Well, what number can I take out of all of these? Hopefully you're thinking, oh, that's right. 3 can be taken out of all of these. X squared can be taken out of all of these. And a y can be taken out of all of these. So 3x squared y can be taken out of all of these. What does that mean we're left with? Well, we're going to be left with 3. X squared y is on the outside. Remember, I'm dividing that out. What am I going to be left with? Well, inside I'm going to be left with 3. And then x squared and x squared, the x's will be gone. And I'm left with y, just 3y. Minus, now 3 divided by 3 is 1. X squared divided by x squared is 1. Y divided by y is 1. It's just 1. That's right, just 1, folks. So you're left with 3x squared y on the outside. That is a common factor. And the remainder is going to be 3y minus 1 on the inside. Moving on. Another example. Simplify each polynomial, then factor. So, you're going to be given a giant polynomial that you have to simplify. That is, collect like terms. Once you collect the like terms, you can then common factor. So, what does that mean? Well, first collect the like terms. X squared, you're going to collect 6x squared minus 2x squared, which will give us 4x squared. Minus 4x plus 12x is going to give us plus 8x. Plus 3 plus 11 will give us plus 14. So now we've collected all the like terms. Next step is to find the common factor. What number can be divided by all of these? Hopefully you're thinking, oh, that's right, not a 4, because 4 can go into here and here, but it can't go into here. So we're probably looking at 2. 2 can be divided by all of these. That's right, 2, folks. So we're left with 2 on the outside, and inside will be 2x squared plus 4x plus 7. And we close that bracket off, folks. Okay, let's look at the next one and see what we can do with b. Now, some of you might be thinking, can we keep going here? Well, in some cases we can keep going, but we don't actually learn this until grade 10. At this point in time, all we're looking at here is being able to common factor. So that's what we're focusing on, is being able to find a common factor. Next part, 7x squared and minus 4x squared gives us 3x squared. Minus 4x minus 20x gives us minus 24x. And then plus 9. So now what we have to do is look for a common factor. That's right, 3 can be taken out of all of these. And when we divide out 3 out of all of these, we get 3 on the outside, and left on the inside is x squared minus 8x plus 3. And that's the end of part B. Okay, moving on. Let's look at another example. Let's look at a long one here, folks. So here we go. Nice and long. Looking at a question like this, first thing you got to do is look and see if we can simplify it in any way. That is, collect like terms. So I can grab a bunch of x cubes. 10x cubed minus 4x cubed minus x cubed is 5x cubed. Minus 5x squared minus 15x squared is minus 20x squared. And plus 15x plus 5x is plus 20x. So one more time, 10x cubed minus 4x cubed minus x cubed is 5x cubed. Minus 5x squared minus 15x squared is minus 20x squared. Plus 15x plus 5x is plus 20x. Okay, and those are the combinations. And now what we have to do is common factor here. What number can I divide out of all of these? Hopefully you're thinking 5. I'm really hoping you're thinking 5. Another thing we can divide out of all of these is an x. 1x can be divided by all of these. So 5x out of all of these terms, and we're left with 5x cubed over 5x leaves us with 5x on the outside and x squared on the inside. And minus 20 divided by 5 is minus 4. X squared divided by x is just x. 20 divided by 5 is plus 4. And then x divided by x is gone, so we're left with x squared minus 4x plus 4. And that's all, folks. We do not need to go further than this. Not at the moment. In grade 10, we'll be learning a lot more about factoring and spending a lot more time on questions like this. All right, folks. Well, that's the end of the lesson. Have a numerical day.